Hi students, I'll be solving two similar problems, alright, that I discussed in the last video in order to ensure that you get an idea of how to solve these kinds of problems in case these kinds of problems do come in the exams. Although chances are very less because these are very basic leveled problems, alright. You will get to find their applications directly, but directly these problems won't come, but indirectly you might find the application of these problems in case of the exams that you will be appearing in. All right, so you can consider all these problems to be a step, just one step of the very big problem that you have to solve in your particular examination. So as we see that now we will be integrating sine of x minus alpha divided by sine of x plus alpha into dx. So how do we go about this particular problem? Now, as I told you, focus on the denominator. We have an x plus alpha in the denominator. So our first concern will be to bring that x plus alpha in the numerator as well. So how can I do that? Let's say I have sine of x plus alpha here. All right. So I have taken an alpha, which means I have to subtract an alpha in order to ensure that in place of x I just have an x. And already in the problem I had a minus alpha. So in the problem I just had an x minus alpha, but in order to bring this kind of configuration of x plus alpha, what I did is I added an alpha with x. Now since I added an alpha, I have to subtract an alpha in order to neutralize both, so that finally we get an x minus alpha only. Okay, remember when you are forcefully trying to induce something, all right, like I forcefully tried to induce plus alpha, my immediate responsibility will also be able to neutralize it, so that ultimately the main function doesn't change. The main function should remain sine of x minus alpha only. As here when we cancel plus alpha and minus alpha, I have a sine of x minus alpha only. Okay, but we have just broken this down in this particular form so that we can solve the problem easily. All right, the very next step is nothing but sine of x plus alpha minus of 2 alpha. Just added them both. I hope you know minus 1 alpha is nothing but minus 2 alpha divided by, I forgot to write the dx, very sorry for that, divided by sine of x plus alpha into dx. All right, so now that we have arrived up till here, our next thing is to actually look to this particular function. We have a sine of a minus b here. So now we will break it into sine of a into cos of b minus cos of a into sine of b divided by sine of x plus alpha into dx. So this is the this is the final part. Now as you can see, after separating like we did in the previous problem, in the first term this gets cancelled, so I'm left with cos 2 alpha, and in the second term this cos by sine becomes a cot of x plus alpha, and this stays as sine 2 alpha into dx. All right, now now let's break it. Cos 2 alpha dx minus integration of cot of x plus alpha into sine of 2 alpha into dx. All right, so as I said, there is alpha here, there is x here, so this is essentially a constant because we are not integrating with respect to alpha, we are integrating with respect to dx, and in the expression we don't have any term of dx, we just have a 1, right? So here we have this as our constant, so this will be placed outside, and inside we will be having this. Now you know how to solve the problem as per the formula. Integration of 1 dx is nothing but x, right, minus of sine 2 alpha Now integration of cot of x plus alpha is nothing but log of mod sine x plus alpha plus c. This is the formula that we have already studied in our last video. Okay, the 4 formulas that I told you, that only we applied here. I'm trying to solve these kinds of problems just to ensure that when such kinds of expressions come, you know what to do. All right, and repeatedly discussing a problem of same variety will also make you more used to with these kinds of problems. Okay, so the more number of problems based on the function of trigonometry you encounter, the better you will be able to face it, not just in your exams but also when you appear for your competitive examinations or whenever you practice at home as well. Okay, one more problem of this type. Say now you have been asked to find out the integration of, say, cos of x plus alpha divided by sine of x plus b, sorry, x plus a into dx. All right, same thing that I told you earlier. You have an x plus b in the denominator, right? So your major task will actually be to bring an x plus b in the numerator as well, because in the numerator you can see there's just an a here. So what I'll do, I'll take a plus b here. So say if I take a plus b here, then can I get back into this form? No, I have forcefully induced a b which I am not allowed to. So what I'll do, I'll simply subtract a b. So ultimately what will happen? I'll only get an x plus a here only, right? Whenever, as I'm telling you repeatedly, whenever you are trying to induce any form of thing in your particular function or whatever, it's important for you to also neutralize it. I introduced forcefully, I induced a plus b here, so it is also my immediate responsibility to neutralize this plus b so that my original function doesn't change. This is something that you need to keep your mind open. All right, and now we know that what is cos of a plus b formula. It is nothing but cos of a cos of b minus sine of a into sine of b divided by sine of x plus b into dx. All right, next, this cos of x plus b divided by sine of x plus b becomes nothing but cot of x plus b, right? Also, this cos of a minus b will be considered as a constant. I hope you know why. As we are integrating only with respect to x, so we must ensure that inside of this integration sign, the function that we have also contains an x. Any other function will be taken out of the integration sign. Though we have a trigonometric function here, but inside of the trigonometric function we have a and b, so there is no such sign of x here. This is why we have considered this entire trigonometric function as a particular constant. All right, similarly here sin x plus b gets cancelled, so we are left with a sine of a minus b. This entire thing will be considered as a constant. All right, so finally what we will be left with, cos of a minus b will be as it is, and integration of cot of x dx, we have studied it. This is nothing but log of sine x plus b, right, minus of sine a minus b. Integration of 1 dot dx is nothing but x plus c. So this stands as our final answer for this particular question. Okay, so now we will be solving more and more problems based on this, and essentially now we will be changing our form also. We have solved a lot many problems, like 3 problems based on the same configuration, just to ensure that you understand that when such problems come, your first task will be to actually focus on the denominator. The kind of function that we have inside of the trigonometric function, the focus will be to bring it into our numerator. Okay. So say for example, we have an x plus alpha here in the denominator. So our major focus will be to bring an x plus alpha also in the numerator as well. Now in that case, we have to forcefully induce a plus alpha in the numerator because we don't have any alpha plus alpha in the numerator. So as I induced a plus alpha, forcefully induced a plus alpha in the numerator, it is my immediate responsibility to neutralize the same by putting a minus alpha. So ultimately the original function stays as it is. Okay, this is something that I'm repeating consistently is because you are not allowed to forcefully induce any particular expression as per your choice and convenience. In case you forcefully induce any of such things, it is also your immediate responsibility to neutralize that particular thing that you have induced so that the original function essentially remains the same. Okay, I've explained you a lot. All right, though we have solved, you can say that the last, essentially the last 3 problems that we solved are equal to 1 only. Okay, because even though by physically it might appear as 3 problems, but it is actually 1 problem only, and that is because all the problems have same configuration only. There is nothing new to learn from here, but I just practiced it in case you face any issues. You will be able to understand it now. I hope you really liked this video. So please don't forget to like, share, subscribe, and don't forget to hit the notification bell icon for more of such exciting content. Many more exciting videos are waiting for you. All right, so now let's move on to the next problem.